your inequalities in slope-intercept form. Okay, so what I want you to do is take out your packet, and here I have it, and I want you to go to lesson 1, okay, and pass the unit vocabulary, pass the next step for success, and in lesson 1, I want you to go lesson 1 video summary, which is right here. So as you're watching the video, I like you to jot down important ideas. I gave you 2 graphs here, which you can copy 2 examples that you're going to use as your models. Okay, and then here you can write questions or comments that we can go over in class. Okay, so let's go to the lessons. So the first thing I want you to do, or I want us to do, is compare equations and inequalities and how they're a little bit different than each other when solving and representing their solutions. Okay, so it's basically covering what we know so far. So solving the equation. An equation is 2 expressions that equal each other, right? We have an expression on the left called x plus 6, which equals the expression on the right, which is 10. So to find the solution of this, we'll use inverse operations. We'll do minus 6, minus 6. X will go, sorry, the 6's will go away because they equal to 0. X is equal to 4. So what does that mean? It means that 4 is a solution of this equation, meaning if I went back to the original equation and replace x with 4, I would get 4 plus 6 equals 10. And if I add 4 and 6, I get 10, which is exactly the same value on the right side. So 4 is the solution to this equation, and there's nothing else that would work. So if I were to draw this or represent this solution on number line, here's what I would do. Here's 4, here's 5. Let me write some numbers to the right of 4, some numbers to the left of 4. And to represent 4 as my solution, I would draw a circle on top of the 4, and I would shade it, which means that 4 is the solution to this equation, and nothing else but 4. And you can try other numbers, pick 5, plug it in here, and go 5 plus 6, and you'll know that you get 11, and definitely 11 is not equal to 10. Or pick a value to the left of 4, I don't know, pick a 0, and you get 0 plus 6, and 0 plus 6 is 6, which is not equal to 10. So the only value that works is 4. Okay, let's see how that's a little bit different with inequality. So let's start by solving this. Minus 6, minus 6. This goes away because it becomes 0, and x is greater or equal to 4. So that it's saying that x, the number that we don't know, that can be added to 6, right, that's going to equal to a number that's greater or equal to 10, can be any number greater or equal to 4. So let's draw that on the number line and represent the possible solutions. 4, 5, 6, 7, 3, 2, 1. Again, we would start with 4. We would shade 4 because 4 is part of the solution, right? And now I'll substitute in a second here to show you. And it says that any value greater than 4 also would work, right? So that would be the solution to this inequality. Let's do some check. Let's do some points here. Let's check. Well, let me pick 4 first of all. If I pick 4, I get 4 plus 6, which is greater or equal to 10. 4 and 6 is 10. And 10 is not greater than 10, but it's definitely equal to 10. So 4 definitely works. So 4 works. Let me do another check. And I'm going to pick, I don't know, let me pick a number way to the right of 4. Let me pick 12. So if I do a check with 12, right, I'm going to go 12 plus 6 is greater or equal to 10. 12 plus 6 is 18. And 18 is definitely greater than 10. So does 12 work? 12 is also work. If you wanted to, again, do another point, and this time let's pick a point on the left side of 4. Let's pick 1, for example. Let's do a check right here. Let me find a little room. Let's pick 1. 1 plus 6, greater or equal to 10. 1 plus 6 is 7. And you can tell that 1 is not greater or it's not equal to 10. So 1 does not work. So this value doesn't work. So again, the solution to this inequality is 4 and any number to the right of 4. Okay? And that's how it's different than an equation. In an equation, we had only one solution, right? One number that would make that equation true. And in inequality, we have a range of numbers that would make that inequality true, right? 4, in this case, any number above, starting from 4 and above it. Now, what's the difference? Same numbers, but the only thing I'm changing here is the inequality. So minus 6, those two become 0, so I get x is greater than 4. What's the difference here? Well, if I draw the same number line, 1, 2, 3, 4, 5, 6, 7, and I put a circle on top of 4. Well, this time around, I'm not going to shade in the number 4 because number 4 is not part of my solution. But any number greater than 4 will be. So look at the difference. Very small difference. Here it says that 4 is part of the solution. Therefore, I shade that circle, right, to show that 4 is part of the solution. And here, 4 is not part of the solution. Therefore, I leave it open. So I'll do a couple of checks. And let's start with 4. Well, let's do a little check here with 4. So if I put in 4, I get 4 plus 6 is greater than 10. 4 and 6 is 10. And is 10 greater than 10? It is not. So 4, again, like I said, is not part of the solution. Therefore, this circle here is not shaded. And if you pick any other number now greater than 4, let's just pick 5. So let's do a check. And we go 5 plus 6 greater than 10. And 5 plus 6 is 11. And you'll notice that it's definitely greater than 10. So 5 is part of the solution. And again, if you did, you can again pick a number to the left of 4, and you will notice that those numbers would not be part of the solution. So there's a difference between equations and inequalities. Okay. So again, let's go over this. Inequality, this sign here means less than. This one means greater than. This means, the next one means that it could be less or equal. And the last one says that it could be greater or equal as well. So how is that going to change in the graph? Right? It's going to change in the graph. In the graph, we're not going to use open circles or shaded circles, right? In the graph, that's going to translate to either a dashed line. An open circle, we're going to use, instead of open circles, we're going to use dashed line to represent that it's not part of the solution. And to represent as part of the solution, we're going to use a solid line. You'll see what I mean in a few. Okay, and besides that, we're not going to point the arrow either to the left or the right number, but instead we're going to shade a section or area above the line that we're going to graph. Okay, so let's take a look at how that works. Well, let's start with something that you already knew how to do. Y equals 2x plus 1, and equation, linear equation. Well, things that we know. First, it comes in this format, in the slope-intercept format, right? Where our 2, or our m, is our slope, and our b is called our y-intercept. The y-intercept is the point in which the line that we're about to draw crosses the y-axis, and the slope, as you know, it's our change in y values over the change in x values, or if you learned it as rise over run, that's fine too. Or remembered as rise or run, that's fine too. So in this case, our slope is 2, or better yet, I'm going to write it as 2 over 1, right? And that's the easy way to graph, remembering the change in y and the change in x values. And then the y-intercept is the point in which the line we're about to draw crosses the y-axis, so we're going to start there. Here's y equals 1, so we know there's a line, right? And because we also know that the slope is positive, we know that our line is going to go up from left to right. It's going to go up. So let's get a few points, right? And then connect them to get our line. So the change in y value is 2. So from y value to y value, we're going to go up 2, and then x value. So up and down. You can put an arrow like this, right? Remember, put an arrow like this means that you're going to go 2 units up, and then left and right, make sure you go 1 unit up. We go 2 up, and then you have to know that we have to go right, and the reason we go right is because when we connect these 2 dots, our slope has to be positive, and that's a positive slope going up. If you had gone left, you go 2 up and go left, and then you plotted it and you connected these 2 dots, you would have a slope that goes down, and that would be incorrect because right off the bat you were told that the slope was positive. Okay, so let's do this. So we get from 1 our y-intercept, changing y values is 2, so we go 2 up. Changing x value is 1, so we're going to go 1 right because it's positive slope, so we'll just get a few more points. 2 up, 1 right, 2 up, 1 right. Let's repeat the process on it down, and I'm just going to show you that you only need 2 points to create a line, but for the purpose of this, putting as many lines as we can to show you y equals 2x plus 1. Now, in an equation, right, it means that any point on this line is a solution to the equation y equals 2x plus 1. Let's pick a point and test it out. So let's pick this point right here. This point here is -2, -3, and let's plug it in our equation. So we got y equals 2x plus 1, and we're going to try the point -2, -3. See if that's a solution to the equation. Remember, this is your x and y coordinate, so we're going to replace. We get -3 equals 2 times -2 plus 1. -3 equals -4 plus 1, and -3 equals -3. So notice that that point is a solution. And again, you can pick any other, and I'll do one more. I don't know, let's pick this guy here. That looks like 3 and 7. So let's try point 3 and 7. Again, y equals 2x plus 1. We're going to go 7 equals 2 times 3 plus 1. 7 equals 6 plus 1. And again, 7 equals 7. And again, it's a solution to our equation. Now pick a point that's not on the line. And let's pick a positive number, positive point to make our life easier. Let's pick the point 4 and 2. So y equals 2x plus 1. And we're going to test the point 4, 2. So remember, this is your y coordinate, x coordinate, this is your y. So this got 2 equals 2 times 4 plus 1. 2 equals 8 plus 1. And 2 equals 9. And that's obviously not true. So 0.42 does not satisfy, right, does not make that equation true. So points that are on the line make this equation true. Points that are not on the line don't satisfy that equation. Okay? So how does all this differ in an inequality? Well, remember what I said, in a graph, it's going to change in 2 ways. We're going to use either dotted or solid line, and then we're going to shade a region to show all the possible solutions. It's not going to be the points on the line. Well, it's going to be the points maybe on the line, or not on the line, plus a whole region. Well, let's see what I mean by that. So let's graph that. Well, we're going to graph this. It's the same number. So again, this is our slope. This is our y-intercept. Right? So our slope, again, changing y is 2, and then changing x is 1. So let's use that. So again, our y-intercept is 1 right here. We're going to go 2 up, 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right, and 2 down, 1 to the left. Okay, same exact line as we had before. And I'm going to connect them. Now here is the difference. Oops. Before I even drew that line, it's a greater or equal to sign. So when you see a greater or equal to sign, or even a less than or equal to sign, you're going to use a solid line, and that's a solid line. Okay, right here. A dashed line would be something like this, right? And it's solid because it has the equal signs, meaning the points on this line, in this case, are part of the solution. Let me draw that first. So, now, in an inequality, okay, we have to pick a region. Either the points above this line are going to be part of the solution, or below this line are going to be part of the solution. So, one way you can do this is to test them. So what I'm going to do is test 3 points. I'm going to test a point on the line, I'm going to test a point above the line, and I'm going to test a point below the line. So let's take a look at a point on the line. So let's take a look at this point right here. Let's use a point 2, 5. I'll use a point 2, 5. And the point 2, 5, I get 5 is greater than 2 times 2 plus 1. And then 5 is greater than 4 plus 1. And 5 is greater than 5. And obviously that's true. So it's telling you that point on the line, and again, you can put, if you wanted to, you can pick many others and try yourself, but you will see that points on the line will make this inequality true. So that's true. Now let's pick a point that's not on the line, but above that line. Let's pick that point right there, and I'll change colors. And that point's -4, comma 3. -4, comma 3. So we are going to get y is greater than 2x plus 1. We're going to get 3 is greater than 2 times -4 plus 1. And 3 is greater than 2 times -4 is -8 plus 1. And 3 is greater than -7. Is that true? Is 3 greater than -7? Yes, it is. So that's telling you that points above this line, to the left, above the line, like any of these points here, will make that inequality true. And again, you can pick a couple more. Right? You can, I don't know, pick this point over here if you wanted to, pick this point, pick this point, pick this point, pick any of those points that, in this case, above the line, to see if it would make the inequality true. And you would see that they do. So we picked numbers on a number on the line, it worked. We picked a number above the line, it worked. So to show that numbers above the line work, I want you to shade it. And the best way to shade it is to draw perpendicular lines to the line that you just created, and go like this. And try not to be as messy, but something like this. Right? So that is showing me that this region above the purple line are part of the solution. That if you pick any point here in this area, they make this inequality true. Well, let's pick a point that's below the line. I don't know. Let's pick this one right here. That point is 4, 1. It's below the line. We're going to try it. 4, 1. Y is greater than 2x plus 1. Let's replace the values. Y is 1. 2 times 4 plus 1. 1 is greater than 2 times 4 is 8 plus 1. And you can see that already that is not true. 1 is not greater or equal to 9. And 4 and 1, 0.4 and 1 failed to make this inequality true. So that is not part of a solution. So yeah, that's pretty much the difference between an equation, graphing an equation, and graphing an inequality. We'll try a couple more. So difference between this one and this one is that this one is less than. Okay, so it's going to be the same line. So let's start with that quickly. Our y-intercept, right, and our slope is again 2 over 1. So let me write the slope. Changing y, changing x is 2 over 1. We're going to go 2 up, 1 to, in this case, 2 up, 1 to the right, and again it's positive, right? And we're going to get the same line that we had previously in the previous example. And we know that this line here, the purple line that I just created, it's going to be solid because it's a less than or equal. That's going to be solid. And then now I got to pick test points. Well, again, let's pick one on the line. If I pick one on the line, I'll pick the one, what did I use before? I'll pick the same one, 2 and 5. So let's pick 1 and 3 now. Let's pick 1 and 3. 0.13 right here. Well, if I substitute, I'm going to get 3 less than 2 times 1 plus 1. 3 is less than 2 plus 1. And 3 is less or equal to 3, and which makes it true. So again, I picked a point on the line, and it is true, and therefore, and that's the reason we used a solid line, because every point on this line will make this inequality true. And now you got to tell me which side of which region above that line or below that line. Well, when it was greater than, right, let me go to the previous example. When it's greater than, we shaded, right, the region above the line, right? So if we're going to use less than, well, hopefully you can gather that we're going to shade the region under the line. But let's do that by using test points. So 1, I picked a point on the line, and that was true. So therefore, I use a dashed line. sorry, a solid line. Now let me pick a point above the line. Let me pick this point right here. What is that? -4 and 4. If that works, we're going to shade this area. That's what it's telling us, right? So let's see if it works first of all. Y is greater or less than 2x plus 1. We get 4 less or equal to 2 times -4 plus 1. 4 is less than -8 plus 1, and look at that. 4 is less than -7. Is 4 less than -7? It is not. So that point right there failed to make this inequality true. So that's telling you that any point on above the line will also fail to make that inequality true. So we know that it's going to be the other side on below the line, right? That's going to be our solution, but we're going to test. Okay, and I'm going to pick a point. Usually the easiest point is a point 0, 0, right? Because then it makes life. So let's use a point 0, 0. Let's take the point 0, 0 and test it. Y is less than 2x plus 1. 0 is less than 2 times 0 plus 1. 0 is less than 2 times 0, 0 plus 1. Is 0 less than or equal to 1? Yes, it is. Makes that inequality true, which means we want to shade the area below the line. Okay. Rather than me just telling you to, hey, if it's greater than or equal to, you shade above. If it's less than or equal to, you shade below. I'd rather you use test points. In this case, by doing the test points, we found out that a point that was under the line made that inequality true. Okay. Let's do one where this inequality sign doesn't have an equal sign at the bottom. It's just greater or less than. And let me show you how that's a little bit different. So again, let's talk about the two pieces of information that's given to me. One, we have a negative slope, so we know the line is going to be coming down. We know that this y-intercept is 4, so let me go to +4 and just put a point right off the bat there. So our slope is -3, right? And we're going to put it over 1, so our change in y is 3, our change in x is 1. So let's go, we're going to count 1, 2, 3, and this time we're going to go right. 1, 2, 3, and we go right. 1, 2, 3, and we go right, and we get a few points, and let me get 1 point on the upside. And here is our line, y is less than -3x plus 4. Now, if you remember what we just did, right? So let me just lower this a little bit. We're going to take test points. So we're going to take 3 test points. 1 above the line, okay? 1 on the line, oops. Let me take that back. And 1, actually, I'll leave it like that. And 1 below the line. So let's take a point here. Let's take 5 and 2 first. So let's try the 0.52. You did a 0.52 and you substitute it to see if it makes the inequality true. You could get 2 less than 3 times 5 plus 4. 2 is less than -15 plus 4. And 2 is less than -11. Is that true? No, it's not. So this point that is above the line failed to make the inequality true. So obviously we don't want this area. We don't want this region. So I'm not going to do that. And then, so that's a no. I'm going to take a point on the line now. Let's take the point 1 and 1. If I take the point 1 and 1, y equals -3x plus 4. I'm going to get 1 less than -3 times 1 plus 4. 1 is less than -3 plus 4, and is 1 less than 1. Is 1 less than 1? No, it's not. So I actually made a mistake, right? But I'm actually glad I made the mistake, because now I can tell you that the line, the point that's on the line here, failed to make that inequality true. So instead of using a solid line like I did, I should have used one of these lines, a dashed line. And that dashed line tells you that points on that line will not make the inequality true. So point on this side of the line failed, point on the line failed, so hopefully a point under the line will make it true. So let's pick the easiest point possible, and the easiest point when available is 0, 0. So let me try that point. Bring that to the top a little bit. So again, here's my point, 0, 0. The inequality is y less than negative 3x plus 4. 0 less than negative 3 times 0 plus 4. 0 is less than 4. Is 0 less than 4? Yes, it is. So a point under our line works, so that is going to tell you that all points under this line will work. So the solution, this inequality, is every point that's under the line. Okay. And I have a couple more examples. This one is an equality, and this time around we're having one that says y is greater than x plus 2. So our slope, remember there's a 1 here, so our slope is 1. So just like the slope is going to be 1 over 1, right? Not changing y and over changing x. Our y-intercept is 2, so let's start this. It's positive. We know our line's going to go up, and it's going to go through 2. So 1 and 1, 1 up, 1 to the right. Right, so we know our line has to look like that. You don't need all these points. I'm just drawing it. Okay, so. And in this case, before I even draw the line, our symbol here, our inequality symbol here, is just greater. It's not greater than or equal, which tells us that points on the line will not make this inequality true. So what kind of line I want to use? I want to use the dashed line, and that's exactly what I'm going to do. Okay. So test points. Well, I'm going to take 3 points. I'm going to take 1 point above. Let me pick that one. I'm going to pick 1 point on the line. Let me pick this one right here, the y-intercept, and I'm going to pick a point below the line. So if I pick a point above the line, what is this point? Negative 3 and 5. Let's pick negative 3 and 5. Let's see what it tells us. Well, if I pick the point negative 3 and 5, y equals x plus 2, let's substitute. I'm going to get 5 is greater than negative 3 plus 2, and 5 is greater than negative 3 plus 2 is negative 1. Is that true? It is true. And if it's true, automatically we can come to this and start shading the area above the line, because that means that every point above the line will make our inequality true. Okay? Which means I don't have to do this test point, but for the purpose of us showing you that's not going to work, I want to do it. So now I may pick a point on the line, and the point on the line is this guy right here, which is 0 and 2, which is on the line, and I want to show you that it doesn't work, and therefore that's the reason why we use the dashed line. So y is greater than x plus 2. Let's substitute. We get 2 is greater than 0 plus 2. 2 is greater than 2. Is 2 greater than 2? No, it's not. So that tells you that the point on the line failed, which means all the points on the line will fail. So therefore we use a dashed line. And the last point, a point under the line, and I'm going to use point 0, 0. Y is greater than x plus 2. 0 is greater than 0 plus 2, and 0 is greater than 2. Is 0 greater than 2? Again, no, it's not. And that point is under the line, so that means that points under our dashed purple line are not going to work, and we don't shade it. So the solution to this inequality is any point above the purple line. So you could pick any point above this dashed line, and would be equal to it would be a solution to the inequality. Okay, let's summarize. Determine if a solid or dashed line is used. Well, if you're going to use a solid line, right, and that looks like this, your inequalities are going to be greater than or less than. If you're going to use a dashed line, right, inequalities are going to be greater than or equal or less than or equal. And that's how you know you're going to use dash line. You don't have to. Or you can do a test point. You can pick a point on the line and see if it makes the inequality true or not. But this is the shortcut. And then solution area. Well, if it's greater or greater than, okay, you're going to shade above the line. If it's less or less than or equal to, you're going to shade below the line. Now, to be honest with you, I'd much rather if you pick test points. Okay, so going back to our previous examples, I rather use, well, for here, for example, the symbol was greater than, so you knew it was going to be above the line. That's the area, the solution area. But I'd much rather you take a point, plug it into the inequality, see if it works, and then use that to determine the area that you're going to shade. Okay. We have two special cases here. Sometimes this shows up, especially when I'm doing systems. Y equals greater than 2. What does that mean? Well, first of all, this means that the slope is 0, right? It's a horizontal line where the y values are greater than 2. Okay? Are equal to 2. So, well, the last two problems I want to do is special cases, I guess if you want to call them that way. And you'll notice that they are a little bit different. Okay. Let me rewrite this just for a second as this, y equals 2. So let's, how would you graph y equals 2? Well, y equals 2, first of all, is a line that's horizontal, right? Where all the values, all the y values are 2. Right? The slope is 0, meaning that it's okay. So the last two examples, I want you to, they're special cases, I guess. All right, so we have two more inequalities that I want you to be aware of. But instead of y is greater than 2, I want you to think of it as y is equal to 2 for a second. How would you graph that? Well, first of all, you know that's a horizontal line where the slope is 0. So y equals 2 would be, well, this line right here. Let me shade it. Let me draw the line y equals 2. This is the line y equals 2. We'll talk about y greater than 2 in a second. But that's the line y is equals 2. Now, let me pick some points here and tell you why that is called y equals 2. Well, y equals 2 because if you take a look at this point here, that's negative 6 and 2. This one right here is negative 4 and 2. This one right here is negative 2 and 2, right? This one right here is 1 and 2. This one here is 2 and 2, and so forth and so forth. Every y value on this line is equal to 2. The x can be anything, but the y values are equal to 2. So this is called the y equals 2. So now, likewise, if I told you, I don't know, let's take another line, y equals negative 3. Well, the line y equals negative 3 would be this line right here, right? A horizontal line And if you were to pick any point on this line, any point on this line, and there's infinite number of points on this line, every y value would be -3. So this one here would be -6, -3. This one here would be -5, -3, and so on and so on. Okay? Now, knowing that, let's go to this inequality. This says y has to be greater than 2. I want the region where all the y values are greater than 2. Well, first of all, it's a greater than sign. It doesn't have an equal at the bottom, right? So we know it's not a solid line. So the first thing I'm going to do is get rid of this somehow. And I'm going to go over to y equals 2, which is right here, and I'm going to use a dashed line. Where's my dashed line? Here we go. So that's my line. Now, where are the values? Sorry, where's the region where all the y values are greater than 2? Well, remember when I said when it's greater, the region would be on top of the line? Well, so is this one. So this area has all the points where the y value, the y coordinate is greater than 2. And you can do a test point. Now, we'll pick this guy right here. Well, that point looks like -5 and 6. This is the x, and this is a y. Let's plug in to the inequality y equals greater than 2. Well, the y value at this point is 6. Is that greater than 2? Yes. And again, you can pick any of these points, right? And there's an infinite number of points that you can pick from, right? And all the y values will be greater than 2. So that's what y is greater than 2 looks like. X is greater than -3. Well, if y is greater than 2 was a horizontal line, x is greater than 2 is going to be a vertical line. A vertical line that goes through that goes through -3. And then first thing we should notice is that this is a less than or equal sign. So what kind of line are we going to use? We're going to use a solid line. And a solid line that goes through x equals -3 right here. Just like I said before, with the y equals greater than 2, every point in this line, in this case, has -3. Well, pick this point here, it's -3 and 6. Pick this point over here, it's -4, -3. Sorry, -3, 4. Pick this point at the bottom here, it's -3, 6. So every point on the line, the x coordinate is 3. Now, the inequality here says, hey, I want you to show me all the points, or the area in this case, where x is less or equal to -3. Well, because it's less than, we're going to go to the left, because that's less than -3, and we're going to go like that. So every point to the left of -3 has an x coordinate that is less than 3. So let me pick this point right here. If you look at that point right here, it's -6, 1. If you replace the x value in this inequality, and here's my x and this is my y, you get -6 is less than -3. Is that true? Yes, it is. So that's true. And again, every point to the left, including the points on the line, will make that inequality true. Okay? So hopefully you are making comments and questions on your packet, and you copied a couple, or maybe 3 or maybe even 4 examples that you're going to use as your guide. Okay? Thank you.